Good afternoon, everybody. I thank the committee of AIOC to give me this opportunity to present my paper. It is axial length in silicone oil filled eyes, comparison between manual A-scan and IOL master. I have no financial disclosures. So silicone oil is very often used as a vitreous substitute in eyes undergoing pastana vitrectomy. These eyes invariably develop cataract, especially patients above 50 years of age. Cataract surgery may be combined with oil removal for the sake of convenience of a single procedure. The critical point here being correctly measuring axial length for best refractive outcomes. IOL Master has shown to give good post-operative results in combined cataract and oil removal surgeries. The problem arises in cases where optical biometry cannot be done. Example in cases with media haze due to cataract, fixation problem, or due to unavailability of optical biometry. My primary aim was to compare the accuracy of axial length measurements by ultrasound A-scan and optical biometer in 1000 centistoke silicone oil-filled eyes. The secondary objective was to derive a formula for accurate axial length assessment using routine ultrasound for axial length measurements in silicone oil-filled eyes. We included 50 eyes with 1000 centistoke silicone oil with clear media and patients who gave consent for tests before and after oil removal. This was a prospective, consecutive, non-randomized study on 50 eyes of 50 patients. The axial length measurement was done with silicone oil in situ with a manual A-scan, TOMI AL100, and optical biometry by IOL Master. The measurements were repeated with the same machines 3 weeks after silicone oil removal. As we all know that the axial lengths in oil-filled eyes are overestimated, we used a multiplication factor of 0.7 to get what we call the corrected axial length. Data was analyzed using Stata 14. Agreement analysis was carried out using Bland-Altman plot. Data was then randomly divided into 35 eyes and 15 eyes, that is 70% and 30%. Regression analysis was carried out to develop the best fitted line for predicting the axial length among the 35 eyes, and validation of this new developed formula was done on the rest of the 15 eyes. P-value less than 0.05 was taken as significant. Coming to results, our mean age was 41.9 years. We included 40 males and 10 female eyes. This is the bar graph showing the mean values of axial length. On the left side is with the manual ultrasound A-scan. We can see that the preoperative mean axial length was 31.76 with the standard deviation of 3.09. And after oil removal, it was estimated to be 24.38 and with plus minus 1.69. In optical biometry in the same eyes, the preoperative axial length was 24.7 and post oil removal it was 24.63. You can see that there is hardly any difference between the two. Now this is a bar graph showing the mean difference between optical and manual. In the left side we can see that the mean difference was about 7.05 plus minus 2.39. Now when we used a corrected axial length, that is the multiplication of axial length as measured by ultrasound multiplied by 0.7, the difference reduced to 2.47 plus minus 1.69. The difference reduced significantly, but it is still quite high. This is a Bland-Altman plot between the difference between axial length obtained by optical biometry and manual A-scan and optical biometry. We can see that the difference ranged from minus 0.85 to 5.81. This is the same eyes plotted after oil removal. We can see most of the eyes now staggered around a difference of 0 with a few outliers. Then linear regression analysis was done in randomly selected 35 eyes of the observed data to find the best fitted line and its regression coefficient. We came to the equation y equal to 14 plus 0.3 into manual axial length. This we call the predicted axial length. This is the new formula then which was validated in the 15 eyes. Now in the difference between the optical and the predicted axial length in the development group was very less. It was 6 into 10 to the power minus 6. And in the validation group, it was 0.97. And when we see on the red graph shows the difference between the calculated axial length minus the optical. There were in the same eyes, in the 35 eyes, the difference was 2.15, and in the validation group, the difference was 3.2. To conclude, we propose a new formula to simplify biometry in silicone oil-filled eyes. We do not need to make any changes in the sound velocity of the machine. It is useful in centers where optical biometry facility is not available or in eyes where it is not possible. Early post-op cataract, hazy media, fixation problem, etc. However, it needs further validation on a larger group of eyes. Thank you.
I think it's a very good observation, but is there some message you would like to give? When to do this biometry? Because later on, once cataract develops, you will not be able to do it.
Sir, this formula that we have derived is for eyes with cataract with oil in situ.
Nothing. You told me that you clear media.
So we took the eyes with clear media so that we could do optical biometry and take it as a gold standard so that we can compare axial lengths, be measured by ultrasound, regress them, and then we got this new equation.
But in patients with cataract, you could do this.
It is to be done in patients with cataract in future, sir.
So you
We have
intend the
proposed a
message is
formula.
that you have to do it suspecting that this is a patient who is going to develop cataract and we are going to operate this patient.
No, sir. We did a study where the sample group that we took was patients with clear media so that we could do ultrasound axial length and we could do
I
optical
appreciate your
axial length.
concern. Very good observation. But when to do this for a message for a phaco or a vitreosurgeon, because he has put in silicone oil, he will wait for the cataract to develop. But when to do this?
This is done in cases, sir, if I am a vitreoretina surgeon and a patient comes to me, has cataract, has oil in situ.
Is there any role for preoperative measurement of the eye? That's what he means.
So the best possible would be do a preoperative axial length measurement.
Yeah.
However, in
And
certain
have you considered the change in axial length
Yes,
due
sir.
to band or buckles?
that is why this formula will make it independent of the fact that because patients may have unilateral myopia, or we have put a band or buckle which changes the axial length after the surgery. So even if we have preoperative axial length
So
values,
what correction factor is needed in case if band is used?
so that's what, ma'am. This formula will make it independent of whether a band or buckle is placed.
One more question here. You have used the silicone oil with 1000 centistokes. Most of the studies which are already published on the topic uses 1300
Yes, sir.
centistokes. So is there a difference between your observation as compared to them? Because most of the studies say that it is almost the same if you compare the axial length with the silicone oil or with the normal methods.
So that needs to be validated because that needs to be studied further because we only use this Orosil available to us, which is 1000 centistokes. We are not using 1300 centistokes. And the correction factor I had used 0.7 was done by Murray in 1300 centistokes. Thank you, sir.
Thank you.